In section 5.6, we're still working with vectors. Now we're moving on and looking at things three-dimensionally. So in addition to our x-axis and y-axis, we also have a z-axis. So let's think about the points of a prism, a rectangular prism, as in terms of this x, y, and z. Let's say that if we have a rectangular prism, and so we're going to go along with the x, y, and z just like we're saying here. Let's say that you know that this point back here is at 0, 0, 0. There is our origin. And then a space diagonal across coming at us up to this front point here. Let's say that this front point is at 6, 8, 12. Then we should be able to, between the rest of these points, we should be able to figure out what all these other points are. For example, to go from here to here. Well, that's along the y-axis, just like we're showing up here. And so here's our y point. So that means we didn't go up, we didn't come forward, we just went over. So this point would be at 0, 8, 0. And if we were to go from this point just straight up, we didn't move towards the x or to the y, we just came up. Here's our z values. So the coordinates for this point should be 0, 0, and 12. Now if we put that together, we move over here and then up here. Coordinates for this point, we did not come this way at all for x, so we're at 0. Then we should be at 8, 12 for those points. Now from this point straight forward. Again, we didn't go move our y or z values, we just came ahead, so we moved up 6. We knew that from here. 0, 0. Now we go up from that point, so we just moved our z value. So now we're at 6, 0, 12. If we were to go from here over, now we didn't move our z at all, but we did move y, so now we're at 6, 8, 0. So based on these 2 points, we were able to figure out the rest of those. Now something else we can do, imagine that space diagonal, that vector coming across here. If we have one from this point coming out here to this point, we have some different formulas we can use. Now first of all, we have an angle here from the y-axis to this. Let's say that's beta. And then from the x-axis to that same vector, let's say that's alpha. And then from z to that vector, let's call that gamma. And so now what we can do is we can take the cosine of alpha, or the cosine of beta, or the cosine of gamma, and we can find, using our same values as we did before, we could say that we have our a component, because we're talking about the x value here, over the magnitude of our vector to find that angle. Or we could take our b component and the magnitude of the vector to find that angle. Or we could take that c component along with the magnitude for that. Okay, so to go along with that, what we're saying is that if we have a vector, we could write this as an I component. Here's our j component. Now we're adding a third one because we're talking three-dimensional. So we have c, and then let's say this is our k component. And so this is our vector here. And so then to go along with that, as far as finding that magnitude, well, we're going to take the Pythagorean theorem and make it three-dimensional. And so we're going to take our a squared and our b squared and our c squared to find that magnitude. And again, if we're talking about a unit vector, then we have our vector divided by the magnitude of the vector, and that'll give us our unit vector. Now here we have our two vectors. Again, we're three-dimensional. Let's say we're going to find the dot product. Same idea. We'll take our I components A1 times A2 plus our J components, B1 times B2 plus our K components, C1 times C2, and that will give us the dot product between these two vectors. Say we're looking for the angle in between these two vectors. Same idea, we're still going to take the dot product, just like we just did here, and again we're dividing by the magnitude of vector V times the magnitude of vector W. Now let's say that we're talking about these points. Let's say we have point 1 has coordinates at x1, y1, z1, and point 2 has coordinates at x2, y2, z2. If we're going to talk about the distance in between those points, just like we just showed before, it's basically Pythagorean theorem, three-dimensional. I'll take the difference in between my x values and square that. Take the difference in between those y values and square that. And take the difference in between our z values and square that. Add them all together, take the square root. Now if we're talking about a position vector in between those 2 points, let's say that one of those points were not at the origin. So to find that position vector, just like we did before, only now we're talking three-dimensional, my I component would be x2 minus x1. Remember, you always subtract whatever your terminal point is from your initial point. That'll give us our I component. y2 minus y1 would give us our j component, and z2 minus z1 would give us our k component.